So everyone should be attempting this warm-up. Has everyone attempted both of these? Yep. All right. What is the problem in each of these examples? We have repeated letters. Good. So we know, oopsies. So we know that we're not going to be able to just do 3 factorial and 7 factorial. Okay? Does everyone understand that fact? That we can't just do it like those are all different letters, because when you've got those repeating letters, some of those words would repeat also. Yes? This is kind of like your after party question. All right? So, how am I going to come up with how many unique permutations there are for zoo? Could I write this one out? Yeah, I could probably write this one out. We've got 1, 2, 3. Mathematically, how do I do this? Very good. How'd you get 3 factorial? Good, 3 factorial. Or 3 choose 3, that would be another way to put this on top, over what? 2 factorial. And why'd you do 2 factorial, Alex? Yep, because we have to get rid of all the different arrangements of those 2 letters that are the same. Okay? So 3 factorial over 2 factorial, which is 6 over 2, which is 3. Question, yes?
Could you do 3 choose 3 divided by 2? Or would that only work in this case?
You could, okay, so the reason that works in this case is because 3 choose 3 is totally fine for the top. That will always be okay for the top. Okay? The bottom being just 2 only works because 2 factorial happens to be 2. Okay? On the bottom, you have to have all the arrangements of your repeated letters. So let's see how that's a little bit different in bubbles. What would go on top in bubbles? 7 factorial. And what would I need to divide out? Good. How do we get 3 factorial? There's 3 letters that are exactly the same. So I would divide by 3 factorial. And what do I get when I do that? 840.
What if there's like
Good. So if there were two different letters that were repeated, then on the bottom, you would just multiply together all the factorials you would need to divide out. So say this was Bebbles instead of Bubbles. Okay? We would do 7 factorial over 3 factorial times 2 factorial. Okay? Any other questions? All right. So today we're going to kind of tie some stuff together. Nothing we do today is really new. It's just presented in a teeny bit different format. We're going to do some practice with percents today rather than fractions. Okay? But we're going to kind of tie together all of our properties of probability that we have been using throughout this unit. Okay? So what I've got listed up here are things that you want to make sure you know, things you want to have memorized, things you're very comfortable with. Now, you know everything up here. It just might be written in a little bit different notation. Okay? What does this P and then parentheses mean? Probability of. So this first one says the probability of A and then B. So that means the probability of one event and then another event. Well, what's the key word here? And. So when we have and, what do we do with our two probabilities? Multiply. So that's the probability of A times the probability of B. Any questions on that one? Okay. Probability of A or B. What do we do when we see or? Add. So we've got the probability of A plus the probability of B. Anytime we see an or. Okay? If the probability is of A or B, but not both, so these are examples where we wanted all the girls that were over 16 or over 6 feet tall, right? Do you remember these questions? All the black cards or a face card, okay? So what we would do is we add the two probabilities, probability of the first one plus the probability of the second one, and then we subtract out the probability of the overlap. Okay, the ones that have their foot in both of them. These are called mutually exclusive events. What that means is if it's in one category, it cannot be in the other category. That's what mutually exclusive means. Any questions on that one? Okay. And the last one, the probability of not A. The probability that A will not happen is always 1 minus the probability that A will happen. Okay? This is kind of what we were talking about with those cans of tomato soup. The probability of no cans of tomato soup, well, the opposite, or the not of no cans, is at least 1 can. So that was 1 minus 1 can of, at least 1 can of tomato soup. Okay? Are there any questions about these properties? Does anyone need more time to write them down? Okay. All right, here we go. You don't have to write this whole thing down, just kind of, you need the probabilities, okay? But I'll go ahead and read it. Suppose a particular kind of calculator uses 2 chips. Chip A has a probability of 70% of being defective, and chip B has a probability of 80% of being defective. So just kind of write down this key pieces of information right here. Chip A has a probability of 70% being defective, and chip B has a probability of 80% being defective. Okay. If one chip of each kind, meaning we select a chip A and a chip B, we want to find the probabilities that different things happen. Okay? So here's the first thing we want to find. We want to find the probability that both are defective. So what's another way I could say that? Both are defective. A defective and B defective, right? Both would be A defective and B defective. So how could I find this? I'm not going to add because we've got and. Multiply. Okay? So instead of multiplying 70%, what's it easier to multiply? 0.7. Okay? So we can multiply 0.7 times 0.8, and what do we get? 0.56, and we want our answer as a percent. So as a percent, what would we get? 56%. Okay? On your test, it would say leave as a percent or something like that. On the certain questions, you're supposed to leave as a percent. All right? Any questions on that? All right. Now I want to find the probability that A is not defective. I'm sorry? No, it's just asking, what's the probability that A is not defective? Just A by itself. What's the probability that A is not defective? 30%. How do we get that? Good. 1 minus, or 100% minus the probability that it is defective. So 1 minus 0.7 is 0.3, or 30%. Okay, we always want to give our answers in percent here. All right, we okay so far? How about B is not defective? What's the probability that B is not defective? 20%. How'd you get that? 1 minus 0.8 will give us 20%. What about neither chip is defective? Neither chip is defective. Okay, we are going to multiply, and I hear some of you on the right track. What are we going to multiply? Good. 30% and 20%, 0.3 and 0.2. And what do we get when we do that? 6%. Okay? Got to be careful with your decimals here. Some people see that and want to say 60%. Okay? But when we multiply those, we will have 6%. Questions? All right. How about the probability that at least one chip is defective? At least one chip is defective. Two different ways we could work this. Ideas. Haley?
Subtract 6% from 100%.
Good. We can go ahead and do 1 minus 6% because that we could think of this as 1 minus the probability that no chip is defective, which would be 1 minus 0.06, which gives us what? 94%. Can anyone think of another way to work this? A little longer this other way. Yeah. So what are the different scenarios with at least one chip? Could we have A defective, B not? Okay, so what was the if we have A defective, that's 0.3, and B not defective, what's that? Or sorry, A not and B is defective. What's that probability? 8. All right. So this is A not defective, B defective, or We could have A defective, B not. Or could they both be defective? Yep. So, or we could have 0.7 times 0.8. If you add all those up, see what you get. You still get 94%. All right, so either way works, whichever way comes to you. All right, and either way gets us our answers. All right, any questions on those? Okay, I'm going to pass out your homework in just a moment. Here's what I want you to pay very close attention to on your homework. What'd I do?
No, go ahead. It's laughing.
Oh, okay. That's it. Yeah, I told you we're not learning anything new today, just kind of tying it all together. Here's what you got to pay attention to on your homework, okay? A lot of you have the right ideas, you're on the right track. Now what you have to focus on is your accuracy, okay? There is no partial credit on this stuff because I don't see what you type in your calculator, right? I don't see if you choose NCR or NPR. I don't see how you reduce your fractions or whatever. So what you are going for on your homework tonight is your accuracy. Okay? Because on your test on Monday, there's no partial credit. You gotta get through all this, okay? You have your calculator, so there's no there's no leniency with calculation errors because you've got your calculator right there to check yourself. Okay? All right, let me pass out your homework.